Section 7-4, long title here. This is called Constant Rate of Change and Direct Variation. And if we're on page 376, this is described, there's a few vocabulary terms here. So it's describing linear relationships. And so the word linear, remember, has the word line in it. So we're thinking of a straight line. So when we look down at the three graphs at the bottom of that page, it talks about constant rate of change. So the two on the left are constant rate of change. They're a straight line. It's the same up and down per every one. So those become straight lines. And notice the line doesn't necessarily have to go through the origin 0, 0. Just as long as it's a straight line, we call it a linear relationship. And constant rate of change, right? So that's constant. And then the one on the right is not a constant rate of change, right? That's curving. It's not a straight line. So that's as simple as it gets for the vocabulary. And example 1 here on page 377 says an internet advertisement contains a circular icon that decreases in size until it disappears. Find the constant rate of change for the radius in the graph shown. Describe what the rate means. So in the graph, they've highlighted 3 points. Now keep in mind, anytime you have a line is made up of an infinite number of points. So if I asked you how many points were on that graph, for example 1, you wouldn't say 3. You would say infinite. Well, that's how they make a line, right? It's just point after point after point after point creates a line. Now they've highlighted 3 points. All right, but that doesn't mean that there's only 3 on the graph. All right, so in this case, we're going to pick 2 points. That's all we need to figure out rate of change. You don't have to have all the points. But using the 2 points, we've got 2, 5 and 6, 4. And again, we're going to use this formula of delta y over delta x, which means the change in the y's compared to the change in the x's, the rise versus the run. All right, so if we look at it, how are the y's changing? Well, look at the y values. Just from 5 to 4, what is the change? Well, the change is it went down 1, so I put a -1. How are the x's changing in that same pattern? From 2 to 6 has a rise of 4. It went up 4 when the y's went down 1. So now we have the fraction -1 over 4, which we could say -1/4 centimeter per second. Right? So that would be the rate of change. Now you could also change it to decimal form, which that fraction is an easy one. We get -0.5 centimeters every second. So either way, doesn't matter which way you write it, as long as you simplify your fraction, that is the rate of change. And it is constant because it's a straight line on the graph. Example 2 on page 378 says the height of the water as a pool is being filled is recorded in the table. Determine if there is a proportional linear relationship between the height of the water and the time. Well, first of all, it can't be proportional. There's no way a relationship can be proportional if it's not linear, right? So it has to be at least a straight line to determine if it's proportional. Now, one thing you can tell just by looking at the graph is if the graph is a straight line and the straight line goes through the origin of 0, 0, then you know that it is yes. So in this case, just looking at it, we know the answer is yes because it's a straight line through 0, 0. Now what they're wanting you to also figure out here is determine if this is a proportional relationship, right? So is the height, so the first point we have there is height of 2 compared to the time of 5 minutes. Now, you usually don't put points in a fraction, right? The only reason we're doing this is to determine if each of these points fits a proportional pattern, and to be proportional, the fractions have to be equal. All right, so the next point is 4, 10. So we say we're just relating the x's to the y's, or vice versa. In the book, they actually have it y over x. It really doesn't matter when you're determining proportionality. The next one is 6, 15, and the last one is 8, 20. And I'm putting equal signs, but really we're just trying to determine if they are equal. If they weren't equal, I'd put a slash through it. And we've learned a lot of different ways to do this, right? So one way to determine if these are all equal is to see if they simplify to be the same fraction. And so 4 over 10 simplifies to be 2/5. Obviously 2/5 is already simplified. All right, 6 and 15, 3 goes into those. If I simplified, I would again get 2/5, and this one is divisible by 4, so we get 2/5. So all of these fractions are equal, which means the points are in a proportional relationship, right? So that would mean that, yes, again, we already knew that the straight line went through 0, 0, so it was proportional. But this is another way to tell. And if you are not able to simplify each of the fractions, another thing you can do is just divide. 2 divided by 5 is 0.4. What's 4 divided by 10? The same decimal. 6 divided by 15 and 8 divided by 20, you would get 0.4. Now, if you did these the opposite way, like in the book, and put the y's over the x's, if you divided, you get 2.5. They show that in the book. So again, just as we said before, these are equal, they're proportional, so the answer is yes. All right, example 3, well, we're going to get to that point, but right in the middle of that page 378, they have a couple of vocabulary terms, and they have in the key concept is something important to come back to. But one of the vocabulary terms is direct variation. And what that means is there is a direct variation relationship. If you look at the graph in there, where does the line cross through? Well, it crosses through the origin 0, 0. So they call that a direct variation. Every x is directly related to the y, and you would actually call that proportional. So because you would call it proportional, you also call it direct variation. And so when that happens, when you have a proportional relationship, sometimes they want to know what's called the constant of proportionality. Well, in this case, k in an equation y equals blank x, whatever that number is, in the key concept they have 2 as the k. Well, k would be the constant of proportionality. So in that example, 2 is the constant of proportionality. So for every 2 of x values, there's 1 of the y values. Or vice versa, 2 y's for every x. And as you're looking at it, that whenever we have a straight line, we have a constant of variation. If the straight line goes through the origin, then we call it a constant of proportionality. So that's what we're trying to figure out here. How do we get k? K is the constant of proportionality. Well, k, you can see it in there, is the y values divided by the x values. Same as we kind of did before. In this case, you're just taking the y's and dividing by the x's, and that gives you how it's constantly proportional. All right, so we're going to show that here in this example. All right, so in example 3, it says the time it takes to burn amounts of information on a CD is given in the table. Write an equation that relates the amount of information and the time it takes. That's part A. Part B says predict how long it will take to fill a 700 megabyte CD with information. That's on the next page. So looking at the table, they give you a column for x's, they give you a column for y's, and then they actually tell you what k is. So how do they get k in the third column? They have the y's dividing by the x's. So just take any of those points, take the y values, just take the first point, 10, and then the x value in that one is 2.5. Well, what is 10 divided by 2.5? Well, it's 4. If you put in the next point, 15 divided by 3.75, you would get 4. 40 divided by 10 is 4, and 100 divided by 25 is 4. So k, the constant of proportionality, is 4. And in part A, they're asking for the equation for this situation. Well, if you know what k is, here's what you do for the equation. You just plug in k being 4. That is your answer, right? So whenever we write equations, we don't actually write an x and a y we don't write numbers in for those. When they ask for an equation, usually you leave x and y as just letters, and then everything else you're trying to figure out what the rest of it will be. So since you know the constant of proportionality is 4, that's how it's constantly related all the time. That's the constant of variation. Then we plug a 4 in. Now you can follow the notes because it does tell you that. And then part B is asking you to predict how long it will take to fill a 700 megabyte CD with information. Well, if you look back at the table has the X's or the Y's as the megabytes. Well, if you look at the table, the Y's are the seconds for time. The X's are the megabytes. So when they ask you how long it will take, that's the Y's, and 700 is the X's. So what you do is you plug in that 700 into this equation, right? Because we know y equals 4x, and x is 700 if you look back at the table. So y would be 2800, run out of room, and that would be seconds. So that is your prediction on how long it would take to burn or fill a 700 megabyte CD with info. All right, that is all for section 7-4. Best of luck.